Hello and welcome back, everyone. Today we'll be doing section 11.3, solving with quadratic methods. Okay, so our first problem you may recognize as coming from the chapter 10 style problem. 2x minus square root of the quantity x minus 1 plus 2 is worth x plus 5. So definitely at the moment it's not quadratic. I don't see any x squares anywhere in the problem. At the moment this is a radical equation. Hopefully you remember from our time in chapter 10 that in a radical equation the one thing that was different at the end of the problem is that the check went from being a good idea to an actual written in stone requirement for the problem. Make sure you're actually doing the check, not just sort of faking a check. Really perform that check. So we want to get our radical by itself. It has a minus in front of it, so I'll go ahead and throw it onto the right-hand side, which means this other stuff I will move on to the left side. So then we have 2x minus x is x, plus 2 minus 5 is minus 3. And right-hand side, we were adding root x minus 1 as well. So x minus x is 0, 5 minus 5 is 0, and we added root x minus 1 to both sides. Okay, so the radical is by itself. So next we are undoing the square root by squaring both sides. Another place not to fake your work. Make sure you're showing your work here. So x minus 3 by x minus 3 is worth x minus 1. And go ahead and FOIL out. So x squared minus 3x turns into a minus 6x. Negative 3 by negative 3, positive 9 is worth x minus 1. So we're subtracting x on both sides and adding 1 to both sides. So x squared minus 7x plus 10 is equal to 0. So quadratics, we have several methods. If they don't tell you which method to use, I would start by checking factoring. If it's factorable over the integers, factoring is going to be the fast, less painful way. Otherwise, we'll have to look for square root method, completing the square quadratic formula. So in this one, we're looking to multiply to a positive 10 in a way that will add to negative 7. And sure enough, negative 2 and negative 5 will get the job done. So if it's factorable over the integers, go ahead and use that method. So either x minus 2 is 0, union that up with x minus 5 being 0, and solve from there. So x is 2 or x is 5. Those are only potential solutions. To see if they actually are solutions, remember we do have to check them. We do have to show the work on the check. So we always substitute into the original. So each x is now a parenthesis. I'll try out the 2 first. So 2 by 2 minus square root of 2 minus 1 plus 2. And I want to know, is that the same as 2 plus 5? So 4 minus square root of 1 plus 2, possibly equal to 7. 4 minus square root of 1 is 1, plus 2, possibly equal to 7. 3 plus 2, possibly equal to 7, and 5 does not equal 7. We don't get to keep the 2. We may be able to keep the 5, we're not sure until we plug it in and see. So 2 by 5 minus square root of 5 minus 1 plus 2 is possibly equal to 5 plus 5. Or I was going back to the original. So we have 10 minus square root of 4 plus 2, possibly equal to 10. And we have 10 minus 2 plus 2, possibly equal to 10. 10 equals 10. That does work. So we will circle up the x equals 5. We do get to keep that one. All right. So that is one of our radicals. Next one, we'll go back to our rational days. Early in the semester, we're still having in-person classes. So we're going to solve 2x over x minus 1 minus x plus 2 all over x is worth 5 over the product of x and x minus 1. So this, you may remember, we also had the possibility of extraneous solutions, only if you didn't want to do the longer check like you do have to do in the radical equations, with a rational equation, you can simply identify excluded values. So here, notice in our first fraction, x value of 1 would make us divide by 0. X value of 0 in the second fraction would make us divide by 0, and both of those would make us divide by 0 on the right-hand side. So in our list of excluded values, x cannot equal 1, x cannot equal 0. So we're going to write that out for ourselves. Otherwise, we have to do the longer written out check. So hopefully you remember what we did after that. Find the LCD. In this case, x by x minus 1. And we multiply everything by the LCD. So we have 2x multiplied by x and x minus 1 over the x minus 1. Minus x plus 2 in parentheses by x minus 1 over x. It's equal to 5 by x minus 1 over x by x minus 1. So we multiplied the left side and the right side by x and x minus 1. On the left side, we went ahead and distributed as well. After that, we cancel our 1s. Since x is not worth 1, x minus 1 over itself is a 1. Since x is not worth 0, x over x is a 1. And those same statements hold true on the right-hand side. So then I keep track of what we have left. 2x squared minus the quantity x squared minus x plus 2x minus 2 is equal to 5. You do need these parentheses since you are subtracting this entire quantity, not just the first term. So a little cleanup, 2x squared minus x squared plus x minus 2x plus 2 is worth 5. We'll subtract 5 on both sides. And we've got some like terms in it as well. So 2x squared minus x squared is x squared. X minus 2x is minus x. Plus 2 minus 5 is minus 3. And now we're equal to the 0 that we were after. So again, it started as a rational equation. Now we have a quadratic left. So I'll make a quick check to see if we can factor. This time I'm looking to have a product of -3. So I need one of each sign. My sum is a negative, so little absolute value gets the positive, big absolute value gets the negative. I can get a -2, but not a -1 out of that. And there are no other combinations to try that have the sign properties that we need. So factoring is out this time. If it's not factorable, then we check for square root method. It's not set up for that yet. Square root method, we wanted something squared equals constant. We did not have that set up. So then it's down to either completing the square or quadratic formula. For completing the square, I have two things I generally want to look at. If the leading coefficient is 1, I'll keep looking. If it's something other than 1, it might be better to fix that first. I also want an even number here. Otherwise, I'm going to have to work with some more fractions. Doable, definitely possible. But in this case, if it's an odd, it's a little faster for quadratic formula. So we're already set to 0. So here a is 1, b is -1, c is -3. Watch those signs. So then x is, if you still have to look it up, write it down when you look it up. Opposite of b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. So x is opposite of -1, +1, plus or minus square root of -1 times -1 is +1, minus 4 from the formula, times a is 1, times c is -3. And all of that is parked over 2 times, in this case, 1. So x is 1 plus or minus square root of, we multiply before we add, so 1 plus 12 all over 2. So x is equal to 1 plus or minus root 13 all over 2. So we have two solutions. Neither of them are the excluded values. We get to keep them both. If we had come up with one of these excluded values, we'd have to have thrown it away. Our next one, we're looking at x to the 4th minus 5x squared minus 36 is worth 0. So this one is not any of the equation types that we've looked at so far. But if we recall that x to the 4th is equal to x squared squared, power to a power, we multiply, we have something that at least sort of looks quadratic. So this is akin to having something that looks like n squared minus 5n minus 36 is equal to 0. So here our n, though, is an x squared. So even though this isn't strictly speaking quadratic, because I was able to write it as something squared minus 5 times that something plus a constant equals 0, we can treat it as if it were a quadratic. So again, I'll check for factoring first. If that's available, it's the easiest method. Not all of them are able to be solved that way, though. So in factoring, we're looking for a product of, in this case, -36 and a sum of -5. Hopefully you spotted that that is indeed possible. If we do factors of -36, one of each sign, sum is negative, big absolute value gets the negative. So 1 and -36, 2 and -18, 3 and -12, 4 and -9, and there's our winner. But instead of saying x plus 4 and x minus 9, we have x squared plus 4 by x squared minus 9, and we're still equal to 0. Don't forget, it does have to stay an equation. It can't suddenly turn into an expression for a little while and back into an equation later. So now I'm looking to solve these. I have a multiplication problem ending in 0, so I can set one factor at a time equal to 0 and solve them. Union that up with x squared minus 9 is 0. So the first one, I'll subtract 4 on both sides. X squared is -4. This one, I can use the square root method since we have perfect square equals constant. Square root of x squared is equal to plus or minus square root of -4. Don't skip that step. Make sure you're showing your work. So x is plus or minus 2i. So there's two of our solutions. The other two we can get from our other equation that we made. So x squared is positive 9. Square root of x squared is plus or minus square root of 9. So x is plus or minus 3. Union those together, and there's our 4 solutions to that. 2 in the real numbers, 2 complex non-real numbers. All right. So next up, we're going to do one that is going to save us quite a bit of time in solving. It is going to start as a quadratic, but it will have kind of a unique setup. So you might notice this as something similar to the last problem where we have something squared plus a constant times that same something plus a constant equals 0. So one option would be to FOIL this thing out, get a bunch of like terms, add the like terms together, still bring our 0 down all the way, and then see if we can solve by factoring, completing square, quadratic formula, etc. But if I think of this as my little u or k or n, whatever placeholder variable you think of, we have something that looks like u squared minus u minus 6 is 0. That is definitely a quadratic. And as far as factoring, we're multiplying to negative 6, adding to negative 1, no problem. We would use a negative 3 with a positive 2 to get those jobs done, except instead of an x by itself, we have the quantity 5x plus 7. So if we FOIL that out, 5x plus 7 squared plus 2 by the 5x plus 7 minus 3 by the 5x plus 7. There's our minus 1 by 5x plus 7 and negative 3 by 2, negative 6. After that, just a little simplifying and solving. So this will simplify into 5x plus 4 by 5x plus 9 equals 0. So 5x plus 4 is 0, or 5x plus 9 is 0. And we just solve those one at a time. So x is negative 4/5, union that up with our other solution. So that would be negative 1 and 4/5. So 2 solutions. And again, you can get to these 2 answers by taking the very long way of FOILing that out, hitting your like terms, and factoring what's left. It's much quicker just to do the factoring this way. All right, so then next up, we are going to look at rational exponents. And again, we'll stick to things that can be solved using these methods. So we have x to the 2/3 minus 7x to the 1/3 plus 10 is equal to 0. Here, we just need to recall that x to the 2/3 is the same as x to the 1/3 squared. So x to the 1/3 squared minus 7 times x to the 1/3 plus 10 is equal to 0. And then you should notice our format. This is basically like having a u squared minus 7u plus 10 is 0. That is definitely factorable. We would use a negative 5 and a negative 2. And we're still equal to 0. But instead of our usual just x, we have x to the 1/3. So we'll set each factor equal to 0 and solve. So the first one will add 5 to both sides. X to the 1/3 is worth 5. Other one I'll add 2 to both sides. X to the 1/3 is worth 2. Remember the 1/3 power from chapter 10. That means we have a cube root. So we undo a cube root by cubing both sides. So x is 125. This other one, cube root of x is equal to 2. Cube both sides, and x is equal to 8, and we'll union those up. The most common mistake on this one is sort of stopping at this step. The x is not by itself. If you have an exponent that's something other than a 1, we do have to keep going to finish the problem. Okay, so that should be enough to have you work on. This is section 11.3. So I would recommend 1 to 57, every other odd. If you have any questions, feel free to get in touch with me, and please stay safe out there.